Find the surface area generated when the graph of the function x equals the root of 4y minus y squared for x is between 1 and 2 is rotated about the y-axis. First step is to figure out which version of the integral you're going to use. And so when they say rotated about the y-axis, then the surface area integral will be computed by 2 pi times the integral of x ds. This x is the radius when you rotate about the y-axis. If you decide to do the integral in x, then the x is going to stay as an x, and the ds will be the woman has the x version of the ds. But if you decide to do it in terms of y instead, then this x cannot stay as an x. So what you do is you replace x by the function g of y, and then the ds formula will be the y version of that ds formula. To get a clue, so what you have to do is see what you're given and use that to help you figure out which one of these two to choose. You're given x as a function of y, and you're given a y range. So because of that, we should make the choice of doing the integral in terms of y. If that doesn't work out, then we know we can flip and do it in terms of x, and maybe that will work out. We replace the x by g of y, we go from 1 to 2, and we have the y version of the ds formula. That's where we start at. This y version of the ds formula, we have to simplify this. It's going to be a bit of trouble with this one. Let's work through it slowly. So we need to simplify this formula. It starts with taking the derivative of your function. So the derivative of root of 4y minus y squared is 1 over 2 times that same square root, 4y minus y squared, but then chain rule comes in and says, no, don't stop there. You need to multiply by the derivative of the inside, which is 4 minus 2y. Let's simplify that before we square. The 4 minus 2y is in the numerator. We could take out a 2 and make it 2 minus y, because those 2's can cancel each other. That would be great. And then we'll have 2 minus y all over the root of 4y minus y squared. Now we're ready to square. And when we square both the numerator and the denominator. Squaring the denominator, we lose the root, and then we'll have to square the numerator. Next step in the process is to add 1. So when you FOIL out the numerator, you get 4 minus 4y plus y squared. And now we have to add 1 to that. But we need to combine them first by renaming 1 to be 4y minus y squared all over 4y minus y squared. So this is just our 1. And now we can combine these two together. We have the other numerator, and now our new renaming of 1 is this, and we notice that there's some cancellation. We have a 4y and a minus 4y. We have a negative y squared and a plus y squared. All that's gone, and we're left just with four all over 4y minus y squared. Alright, great. Well, we take the square root of the we take the square root now, which is square root of the numerator, square root of the denominator, and that leaves us with 2 over the root of 4y minus y squared. Alright, well, if that's the case, then what we need to do is now plug this back into the formula. Third step in the process is to plug in and integrate. We have the formula from the first slide, replace g of y by the function, and replace this ds with what our simplified version of it is. G of y was the root of 4y minus y squared, and the root of the 1 plus g prime squared is exactly what we simplified on the last slide. So these conveniently cancel out, leaving us just with the 2. Pull the 2 out with the 2 pi. And we're done. The antiderivative of 1 is just y. And so we just get y from 2 to 1, 2 minus 1, we get 1. So the answer to the question is 4 pi.